Hello friends, today I'm going to solve LeetCode problem number 208, implement trie, prefix tree. So what is a trie? A trie is a data structure used to efficiently store and retrieve keys in a data set of strings. And it has various applications including auto completion and spell checker. So basically, what does trie look like? Let's see here. So we need to create a trie, and we are inserting this word in our trie data structure. So as we saw in this example, in this definition here, it is a tree data structure, right? Which means it is in the form of tree. That is, we have one node and then we have multiple children of that node and so on. So this is what trie will look like. So here in this example we are inserting the word apple, right? So now our trie would be like, it starts from the first letter A and then the next character in this word is P, right? So it will point to P. The next character is again P, so it will now again point to P. The next is L, so it will point to L, and the next one is E, so it points to E, and so on. Let's suppose we have another like word that is air. So if we have another word and we need to insert this in our trie, then we would start from A, and we look that we already have the node A, so we append the character I in our node A because it doesn't have any character with any node with the value I, right? So we append that I, and then R would be appended to I, so we append R to I. So this is how we create our trie. So now let's suppose we have another word, example box. So if we need to insert box, where are we going to start from? The node here is A, right? And for box we'll have a tree which starts from B and then it will continue with O and then X, right? So this is how it will be. So these three are actually separated, but it should be connected in one way. So that is, we are going to connect it using a root node. So or we will have a root node, and the root node will point to the first character of all the words. So we will point to the first character, that is A for this word, A for this word, and B for this word. And if we have a character starting from C, then we'll have that over here. Suppose it's cat, then we'll have C, A, and then T, and so on. So we'll have it so on. So this is how our trie will look like. So what's actually happening here? What's happening here is that for root we have multiple nodes. Root is pointing to multiple nodes, and the maximum number of nodes will be equals to 26 because we have 26 characters in Latin, right? So it's said here, where is it said? Yeah, lowercase English letters. There are 26 lowercase English letters, right? So that is why the maximum length could be 26. Now we cannot, like, if it was a binary tree, what did we used to do? We start from a root node and then we have two nodes, right? So we define those two nodes by the left and the right node. But now here, since we have 26 of those nodes, so how are we going to denote those nodes, and how is that be associated with the root node or the parent node that it's emerging from? So we are actually going to do that in the form of a map, because if you look what's happening, root is basically, root would be the mapping of all of the first characters to the second characters. So let's take this example here and see what does it mean to have a mapping. So what are we going to do is we are going to create a map. So a root node, we start from root node. Initially it doesn't have any values in this root map, and now we start inserting. So we insert the first character in our map, which is a root. So this is our mapping function, and we insert the first character A. So now we have a first character A, and what should the first character A point to? According to this map, it should point to the second character, right? So we have our first character A, and also A points to the second character of another word also. So A points to P for apple, A points to I for air. So that is why A will also be a map. So what a map? Let's add one more word here in this example, that's air. So A will point to the two characters, the second character, right? So A will have P, which will also be a map, and A will also have I, which will also be a map, and so on. So it will be a nested map. It will keep on going in those ways. Now what we need to do is we also need to look at these two things here. So we can insert an apple, and we can also like insert a word app. So we need to check if we have the word apple, we have the word app or not. While we insert our word apple, we have app, right? But we didn't insert our word app in this tree. So how do we like distinguish between apple and app from this node? So what are we going to do is we are also going to create another node, which will be an end node, and this will denote the end of the tree. So if this end is set to true, if the value of this end is set to true, that means that we have the word app in our tree. So every word we insert will have end node which will be equals to true. So basically in our map we'll have an end, and that value will be set to true if it is the last character, else it will be set to false. So now we know how we could solve this problem using maps. Let's start to write our code. So what we first need is we need to create our trie object, right? So we are going to do that by defining our root of the tree. That will be an empty map, and then to this tree we are now going to insert the word. Basically, like to this map we will insert the first characters and so on. So let our map be equals to this dot root. Okay, and now we do iterate over each of the character in our word, and we check if the map already has that character. We just continue to the next character in our word, else we need to add that character, create a new character with create a new map for that character. So what we'll do is if it doesn't have that character, then we create a map. Map for that character, and then our map will be equals to the map, the next one. So what are we doing is in root we have our word apple, right? So we have a word apple, we are inserting it into our root map. So what we do is we first take the first character A, and then we created a map for our root, right? So now we take the first character A and we then insert it into our root. So now while we are inserting, this A will also be a map, a type map. So now next character is P and we search into this map, the nested map. That is, initially we were looking at the root map, now we are looking at the nested map A, and we don't have the character P, right? The map for P. So we insert P inside our map A. So basically it will be like this, which will be inside our root map, and we will keep on continuing. So we will now check the P and then we'll insert the next character P to this, and so on. So that's what we are doing here. And what we'll also do is we'll also check if the map has is and value set to true. So if the map already has a value set to true, then we don't do anything else. If it doesn't have that is and, then we are going to set it to false, because we have not yet reached the end. And then what we do is finally at the end we are going to set our map is and to true. Okay, so this will denote the end of our word in our tree. Now we need to search, right? So how we're going to search is we are also going to do the same, start from the root, and we'll check in our map if we have the character within that map or not. So we start from the word, first character, and then if the map doesn't have that character, then we return false. Else what we do is we move to the nested map, that is a map of C, and then we continue checking. And then finally we also need to check that map is and is set to true. So if it's set to true, we are going to return true, else we return false. And finally, to check for words that have to check for the try which starts with this prefix, it's like the same thing here. So what we do is we'll just copy and paste it here. Okay, and I replace this word here with the prefix and return true if we could find the prefix in our tree. Now let's try to run our code and look if it works fine. Okay, so I have some problem here, undefined. Okay, so we actually need to set it to false here because we have not yet reached our end. Awesome, let's try to submit this. Great. So let's check the time complexity and the space complexity. So while we create our try function, the object, we are creating a new map, right? So every time it's gonna take maximum of 26 spaces, 26 new spaces. So that would still be a constant value because 26 is like a constant number. So that's a constant space and constant time. So every time we are using a constant space while we create a new map. But here while we are inserting, the insertion will depend on the length of the word. So let's see here, if the word was of infinite length n, let's suppose it will, if it was of length n, then our like map would have multiple nodes, right? It will keep on growing in nodes, so we'll create n number of nodes. So that is why if the length of the word is n, then the time complexity will be O of n, because we are iterating over each of the character here, right? And the space complexity will also be then O of n. And now our search function here. So for the search function, the time complexity is O of n, also because we are iterating over each of the character, and the space complexity is constant, similar with this case. So hope you liked it.